Today I will teach you everything you need to know in order to use CMake, and finally make that cool C++ project that you have been dreaming about. Or maybe start learning OpenGL. Have you ever had problems with linking libraries in C++? I know you have, it's horrible. But CMake is the solution for that. And today you will have your first CMake configuration up and running. And if you are here just because you want to get this over with as soon as possible, after you learn these things from this video, you can just take one of my many CMake setups that are plug and play and already configured with the common GameDev and OpenGL libraries, so you can just start writing code today without having to mess yourself with the hard linking step. Now, 99% of people hate on CMake, and for good reasons. It has many problems, but I have a slightly different way of using it, that I learned from a friend that, let's just say, he knows a lot about programming in C and C++, and I haven't seen anyone else do it, and it's 10 times better than what most people do. So this method manages to find fixes for all the common CMake problems, like annoying and slow dev process, bad ID integration, bad project structure, or your program not being able to load files, leaving you with all the benefits, and I'm going to show you all of them in detail, so you can also have a smooth developer experience like I have. CMake also makes your project cross-platform and cross-IDE, so it will also work with any setup that you have. Instead of spending time trying to link libraries, you'll spend more time coding. And it's going to be a practical guide. I'll not just show you CMake, I'll show you how to make a good full CMake setup, start to finish, and you will have many exercises along the way. Most people have very complex CMake configurations, but we are going to keep things very simple. So why should you learn from me and not them? Well, using my simpler methods, I managed to successfully develop and ship a Steam game. And I've been giving my setup to many other people and got feedback every time some didn't work out, so this method is tried and tested. So why would you want something more complicated? And yes, it will work for you. I will introduce concepts one step at a time, with exercises, and cover all possible pitfalls. And if you are here because you just want to get this over with, but don't really care that much about how CMake works, I'll just give you all my CMake templates that are plug and play, so you can just take it from there. But don't just skip around the video, there are many small details that are crucial and took me literally years to find. So if you want to take action and learn CMake for good, this is the video you need. So, what is CMake and why should you use it? CMake is what is called a build system. Imagine you have many CPP files in your project, a few folders with header files, and maybe some external libraries. Well, you need to somehow put them all together. The compiler can't just take your files and compile them. He needs to know what files to use, and where to find the header files, and how to link the libraries. The build system will take care of that. And if you have used Visual Studio before, whenever you add a C++ file, or mess with the linking settings here, all of the settings are added to the build system of Visual Studio. So all of these settings can be done from CMake, but more efficiently. So for example, instead of taking a .lib file and linking it separately for the release and debug options, and do that again if you want to target other platforms like Linux, and then also adding the include pass, with CMake, all you need to do is add 2 lines of code to link a library, and it will automatically work in debug, release, Linux, Windows, on all IDs. It will work if you change the code of that library, you can easily debug the code of that library, so isn't that great? Now, there are other build systems, like Premake, that some people say are better, but most libraries have only CMake support. And again, I basically found fixes for all the common CMake problems. And whenever I want to make a new project, I just copy paste my template. So like, CMake doesn't cost me any time to use at this point. So it is the most common build system, and I have zero problems with it. So why use something else? But that's why it's very important you don't skip around. In the beginning, I had a ton of problems that I learned to fix to get here. So you want to skip my pain and learn to avoid all the pitfalls. So let's dive into using CMake. You will first need to install it in your computer. Link in the description, so you can just go ahead and do that. And then, before you write any CMake code, you need to learn how to use it with your IDE. So in the description again, there will be several learning materials. So in the learning material number 1, you will find a repo. Go ahead and download it. Or you can even fork it if you want to save the exercise that you do inside your GitHub. And there are multiple folders inside. Go ahead and enter CMake Hello World. So, your first exercise is to make this already made CMake project run on your IDE. We can't move on if you don't have that. It's like teaching C++ without ever running it on your computer. Now, there are 2 ways to open a CMake project. The generic way that everyone uses, and the better way. So I'll start with the generic way, because it works every time, everywhere, so it's good that you know about it. But the better way is specific for each IDE, so I will show you that for Visual Studio, But if you have other IDE, no problem. Either use the generic way, or search for a tutorial for that IDE and CMake. And yes, I will give you links for such tutorials. So, to explain how it works, the generic way will just generate a project for your IDE, and then you open that project from your IDE. The better way, however, will integrate the CMake project directly into your IDE, and you will soon see why that has many advantages. So, back to our learning material number 1. Inside the CMake Hello World folder, you will find the CMake list.txt file there. All CMake projects start from this CMake list.txt file, so that's how you know you are in the right folder. And also, that's how you know this project uses CMake. Now, let's open the CMake project using the generic way. So most people open the CMake tool, and you can easily start configuring it from here. But there is a small shortcut that I always use instead of messing with this GUI. You just need to type like 3 commands in the command prompt and you are done. So please, do this together with me. Open the command prompt in this folder. Create a new directory called build. Enter inside it and type cmake ... That's all you need to do. You just create a new build folder and inside it you type cmake ... You can even just create the folder from the file explorer and then enter it. And then type cmake ... here where you have your folder path. And it will do the same thing. Like, isn't that way easier than messing with this tool? Now, inside this folder, you will find a solution file that you can open and run, and that's the generic way to open a CMake project. Most people would stop here, but this way of doing things has many downsides. The integration with the IDE is very weird, and you also need to close Visual Studio and redo this step every time you add a new file to the project. But just know about this option as a backup. Now delete this build folder, and let's move on to the better way of doing things. And again, if you use another IDE than Visual Studio, you'll for sure find a tutorial for that. Trust me, it's not something difficult at all. For Visual Studio Code, you need to install the right extensions, and for CLion, well, CLion uses CMake by default. But for Visual Studio, inside the project folder, right-click and select Open with Visual Studio. Alternatively, once you open Visual Studio, you can select Open a folder with a CMake project from here or from here. So now, you should be able to go from this drop-down here, select CMake Hello World, and then you can press Ctrl plus F5 to build and run. And if this didn't work for you, it's time to troubleshoot. So the project will entirely be generated inside this out folder. So all of the generated files will stay in here, and if you delete it, you can rebuild from zero if you ever have weird problems. To refresh your CMake project, you just need to enter inside the CMake list.txt file and press Ctrl plus S. Also, to view the out folder from here, press this Show All Files button. Now you can easily delete it and rebuild your CMake. So if you can see an out folder, try pressing Ctrl plus S on the CMake list.txt file. Then, if you for some reason still can see CMake Hello World here, or you have other weird bugs, delete the out folder, and again, Ctrl plus S on the CMake. If it still doesn't work, or you don't get an out folder at all, you need to check if you installed the right Visual Studio components. To do that, go inside Visual Studio Installer, and then go here. And you need to have this component installed. If after all these efforts things still don't work, uninstall CMake and Visual Studio and reinstall them. I have seen this actually fix the issue. Okay, now that you managed to run your first CMake project, you can start learning how it works. So we are again inside this project here, that you should hopefully have it up and running. All CMake projects start from this CMake list.txt file. This is like the main file, the entry point, and it has to be named like this, and it has to exist. So if you take a look at a random library on GitHub, many of them will have this file, meaning they support CMake. Now the first line in any CMake project is the CMake version. And this doesn't really matter for what we'll be doing here, because we don't ever use the advanced features. So just copy the version that I'm using. Next we declare a project, and the project just holds the things that you are trying to compile. In this case, we have an executable, but you could also have a library. And the project can hold multiple executables, or you can just make one project for each executable. It doesn't really matter for you. In general, I just make one project where I put all the executables, but in this particular case, I just have 2 projects, each with one executable, and I made each executable to have the same name as its parent project. And as you probably have already guessed, here, you just give the CPP files, and also the header files that you want to be included in that executable. Before we move on to the next exercise, why would you ever want to have 2 different executables? Well, once your program starts to become big, you might end up building tools for it that they share pieces of code, like for example, a game and a level builder for it. You can simply select from this dropdown which one you want to run. And also, you can see here from what project your file currently is. This is very useful if you have duplicate files between projects. So you can select from this dropdown here what project to open, and then don't click this button. Press Ctrl plus F5 like a pro to open and run the program, and then try to open the other one. Now if you want to add a release configuration, because we are in debug right now, you just go here, click this plus, find x64 release, and then Ctrl plus S to save this and close it. But enough rambling. Your next task is to make a very simple CMake project from scratch, just like this one. But don't worry, I'll give you the steps. So create a new folder. Inside it, create the CMake list.txt file, and also a main.cpp file. Next, open the CMake list.txt file and add the basic CMake code to create a project, and to use that main.cpp file. Now you can open it with Visual Studio, and it should all work, except that you also need to write a simple hello world program in main.cpp. Now you can run your program, and if everything works, let's add some more files. Go back and add a second CPP file and a header file. So to add them to your project, you just have to also add them here. Very easy. Now just write a basic function inside the header file and the C++ file and test it. You can also add files from Visual Studio directly, so make sure you press Show All Files here and add a file. Visual Studio will ask you if you want that file added to CMake. This is a cool feature, but we won't actually use it in the final setup, because I have something better. Okay, so now you should have already made your own simple CMake configuration from scratch. If so, before we move on, here are some small details about CMake. So we can actually omit these quote symbols here, and your project will still work. And this is kinda weird, I know, but I just always use them. Also, this is how you write comments. Finally, there are special CMake variables, or rather constants, like for example, CMake project name, that will be replaced with the name of the current project. And variables have a weird syntax, but again, it is what it is, and you can again emit the quote symbols. So these two CMake files are equivalent, and if you have many projects in one CMake, I recommend being explicit and just type the name yourself. Okay, let's move on. So in the repo that you downloaded, go inside the folder linking a library and open it. Here you will see some new things. So first of all, this line is used to set the C++ standard. I use C++ 17, and you probably also want to do that. So this is how you tell CMake that. And if you don't know what that is, you can search online later, but don't worry too much about it right now. So we again make a project and set the C++ standard for this project. And then we add our executable and the C++ file. So let's talk about the other new things. Target include directories will tell CMake to look inside this folder. Ignore the public keyword here. Just add it and don't think about it. All the header files inside the include folder will be automatically included. And notice that I'm using a CMake variable here, so that I don't have to use absolute pass. So if you look inside the project folder again, we have that CMake file, and in the same folder, we have an include folder. Inside it, we just add header files. Then, you just need to click Ctrl plus S on the CMake file to refresh it and load the new header files. So we don't need Visual Studio to add them manually for us anymore. The final two lines remaining have to do with linking libraries to your project. First, you need to tell CMake where to look for other projects, and you do that using this line. So back to our project folder again, I recommend you to make a folder called Third Party, where you put all your external libraries. So this is how it might look once you have many libraries. Back to the CMake. Once you tell CMake where to look for other CMake projects to link to, this is how you tell CMake that you want to link a library to your executable. So this step will be done only once, because you need to tell CMake to look for these libraries only once. But this step will be done for each executable that needs to be linked with other libraries. It makes sense. First you tell CMake that profiler.lib exists, and it is here in this folder, so CMake knows about it, and then you tell CMake that you want to link profiler.lib to this executable. So if you have multiple executables, maybe you want to link this library to some of them, and you don't want to link it to others. And having multiple libraries will look something like this. Now, note that for some libraries, the name of the library might not be the same as the name of the folder. So here we are just telling CMake to look inside this folder, but the library inside could have a slightly different name than the folder it is in. So we can rely on IntelliSense to autocomplete it for you, or just ask ChatGPT for help. Also, if you are wondering how does this loading library works, let's look inside this path. If you go inside this folder, there is a CMake file. So basically, this line tells CMake to look inside this folder for other CMake files to add to the project. And if we open it, it is very similar to what we have been doing so far. The only difference is that it is a library instead of an executable called profiler_lib. So that's how CMake knows about the profiler_lib library. Also, this library also comes with an executable as well, and it is a test executable. So because we told CMake to look inside this folder for other CMake files, it will also load this test executable, and you can run it to test the library. But if we go back to our executable, we can see that it compiles, and it correctly loads the library, and also the header file. So your task now is again to remake this CMake project, and I will hold your hand a little, as I did last time. First, make a new empty project. Here you want to create an src folder, where you put your CPP files, an include folder for the include files, and a third-party folder for the libraries. And in here, you will paste the profiler_lib library that you will link to. To keep things very simple for now, just link to this library that I just showed. And now, rewrite the CMake exactly like I did. But it's important you type it yourself, not just copy-paste it. So after you've done this, you might be wondering, isn't there any way to automatically add all of the CPP files to CMake without having to manually type them? Well, let's go to the third example. And after that, we look at two practical examples from a real project that I shipped on Steam. Because there are some extra problems that can appear, and it's very important you know how to fix them. And also how to best put your project on GitHub. After this, you'll basically understand how my CMake setup works, and you'll just be able to copy it and use it, or change it a little to make it your own, and use it as a starting point. Because that's the goal eventually. You don't want to always do this CMake thing, especially the weird things that I'll soon talk about. You want to have a working CMake setup and reuse it for all your projects. Now let's go into the third example. So in the same repo, enter inside more complete example, and let's open it. So the first new thing is this line. Now it works weird, but this is how you tell CMake to force your projects to link the CPP runtime statically. And it won't work correctly if it isn't exactly like this, so I usually copy-paste these lines, and I recommend you do the same. So what does it mean to link the CPP runtime statically? Unfortunately, I have a lot to explain, but it took me like 100 times more to get to these lines, with multiple failed attempts and insane rage outbursts that go back all the way to my first C++ game 7 years ago. So consider yourself lucky that you will just have this problem solved in a few minutes. So all of these C++ functions that you use, like cout and the memory allocator, are provided by what is called the standard library. The standard library has the implementation for them, and if you compile for Linux, there will be another standard library for Linux that will basically do the same thing, but for Linux. Now you might wonder, why should you care about this detail? Well, the idea with the runtime library was to be shared across programs, so you save on some memory, you save on some RAM, and if a security bug appears, you can just update only the runtime. Well, this in practice doesn't work at all in Windows, because Windows will absolutely and totally fail to find the runtime library for you, even if you have like 100 runtime libraries copies in your computer. Your program can compile and run on your local machine. It probably won't run on their PC, so if you don't plan to give your program to others, then you can just ignore these runtime library things, but you probably want to eventually give your program to others. So to save the other PCs from the stress of not being able to find the runtime library, which will 100% happen, and also to make sure the runtime library on another PC is 100% compatible with your program, everyone just ships their program along with the runtime library. Steam can do this for you, but if you don't use Steam to send your game to others, you need to send your game with an installer for the runtime or something, and probably also for your program as well. So this sounds just stupid, and it is. The idea of a shared runtime was to have it only one on that PC, but it clearly doesn't work on Windows. So people just ship their programs along with their runtimes. So that's why I just link it statically. That means my program comes with the runtime inside it, and I know 100% it will work correctly and it doesn't need an installer to run on other PCs. And I would do the same on Linux, because like in today's world, where you have like 1 terabyte of storage, saving on a few kilobytes or maybe like a few megabytes for a very big library, but taking the risk that that library isn't on the other PC or it is a different version that isn't compatible, just doesn't make sense for me. I just want to make sure my program is as bulletproof as possible, and it's very hard to break it. That's also why I don't use DLLs when making my games, because the program will be harder to break if it has all the things inside it, and also it will be optimized better as well. There is only one small advantage remaining to linking dynamically on Windows, and that is if the runtime is ever updated for a security reason. You can just send that to people. But like, come on, you probably didn't even know about runtimes. Don't tell me that you suddenly care so much about that for your game. You probably have like 10 buffer overflows exploits in your program anyway. And if that rare case indeed happens, do you think I would just send a new runtime to people? Like, what if they change something weird and now it introduces weird bugs? That can happen theoretically only, but in practice, I'm not taking that risk. I'll just recompile my project and send a new version to people to make sure it works. So don't tell me you want to make your shipment process more complex for no reason. Just build statically. Now, I wish I was done with this, but there is one more detail. Most libraries compile the runtime not statically. So that won't work. You need to tell them to link statically as well. And I'll tell you how to do that once you get there. So don't worry. But for now, just know that you can forget about linking statically and all of these details only if you don't plan on giving the project to others to test. Okay, we can finally move to the next lines. So you already know most of the things here. We tell CMake to add some third-party libraries for us, we create a project, and we set the C++ 17 standard. Now we get to this weird thing. So this little line is probably my favorite CMake trick, and if you read the comment, you probably understand what's happening. So adding the CPP files by hand is just like something weird, and having the IDE add them automatically for you is just patching the problem instead of fixing it. So what if we could tell CMake to just add all the CPP files inside a folder? And that is what this line does. Now you don't have to memorize it or understand how it works. You can just copy it every time. So starting from the src folder, it will place all of the CPP files, including CPP files in subdirectories, into a variable called mysources, that when we add our executable, we just use it. So whenever you add a new file and Visual Studio asks you if it should add it to the CMake, say no, because it is redundant. But make sure you enter inside the CMake after you add the file and press Ctrl+S to reload the CMake. And if the reloading ever doesn't work for some reason, you can always delete the out folder to do a clean build. Next we add our include folder, a link to our libraries. So this leaves us with only these two lines here to explain. So whenever you want to open a file, like in this example, if you use relative pass as you should use, you are probably used for this relative pass to mean search for this file inside the folder where the root of the project is if you use Visual Studio. But Visual Studio does a little trick here to help you, and it won't happen when using CMake. When you use CMake, whenever you open your program, no matter if you do that from your IDE or you open it directly, this relative pass will mean look inside the same folder where the program is. Now this is what you would expect to happen, but it means you need to have a copy of the resources in the debug folder and also one in the release folder. And I'll cut on some technical details, but I've seen a ton of cases where in the end you either can't debug your program from Visual Studio or you can't open your program from outside Visual Studio. And I have seen a lot of didactic OpenGL engines from various universities around the world with this problem. So some people literally don't fix this issue, and you literally can't use the debugger. Others fix this issue, but in a very weird way. And I of course have a better solution. So what I'm doing here is I'm defining a constant for the C++ project. So this constant will be a macro that you'll use inside your C++ project, and it will be defined to point to the resources folder using an absolute pass. So this resources folder is inside the root folder of our project, and inside it we have a txt file. We can open the txt file as so using the resources pass macro, and it will work correctly. So no matter where your exe file is, it will work. So you put all your resources in the resources file, and whenever you read or write a file, use this macro. And pro tip, if you make a game, I recommend saving the player's data in a different folder, like so. Now this macro is defined to use the absolute pass, so you use absolute pass during development. But you can't use that when you want to send your project to someone else. So when you are ready to send your project to someone else, you manually change it from CMake to just use relative pass. So let's recap. You write your program, and every time you want to read, write to or from a file, you do it in this resources folder, and in the code, use this resources pass. And if you want to send your program to someone else, you comment this line with the absolute pass, and uncomment the other one with the relative pass. And you recreate your CMake and recompile your program. And all my CMake setups have these things. I know it sounds weird, but trust me, if you try to not use it, it will soon cause you problems. Okay, now we can finally move to the practical things, but I recommend to also take this last example and recreate it yourself as you did with the other examples. For these long weird lines of CMake, you can just copy paste them, and make sure you manage to properly configure this assets pass macro correctly and manage to read from a file. So now let's continue with something very simple. Project structure and Git. So you already saw that I have a src and include folders. And you can also have subfolders inside them, and everything will work using the methods that I showed you. And if you use subfolders for header files, you also need to specify that when including them. But I think that's something good. It makes things more organized. And the git ignore is very simple. So these things are from IDs, and everything built by your project will be placed here. And just in case someone has the build system a little different, we have these extras. And this is another advantage of using CMake instead of just Visual Studio. Because the normal Visual Studio project places the build files all over the place in the least consistent way possible. No wonder your git ignore looks like this in that case. Why would anyone want that when you can have all the build things in one place? And for external libraries, I just add them directly to the repo and push them on GitHub, and that's it. And if I have 10 projects that use the same library, I will just copy them 10 times. And yes, I'm basically compiling all the libraries with my project. So that means I'm not using lib and DLL files or stuff like that. Now many people will disagree with this, or they would say I need to use git submodules. And for some reason, I find it very hard to convince beginners to do things my way. Probably because most examples online use submodules or install their libraries globally. And in reality, they just do that because that's what they saw. But if you pause for a second and think a little about the arguments that I'm going to give you, you will see that it's way more convenient to do things this way. So you can read this if you want. And I would say at least try things my way once if you aren't convinced, and you will see that it is very convenient. Okay, we now move to a real complete example. So learning material number 2 that you can find in the description is my go-to game dev CMake setup. I recommend taking a look later on your own at how I did it, and just use it like it is, or make one of your own from scratch in a similar manner. So one thing I haven't really talked about is linking to libraries, and yes, I showed you how to do that, but in practice, you'll have weird problems that there is unfortunately no easy fix than gaining some experience. There might be some very little details that it's impossible to know without being literally an expert at that library that you just downloaded and that you can't find anywhere. That's why I recommend you to start with my setups that already work and then maybe try to do that on your own. But the easiest way I found to link a library to CMake is to ask ChatGPT to do it for you, like I do right now. Make sure you give it all the details, or maybe your whole CMake script, and mention that you want to link the library statically. And I know some people will disagree, but here is my point. If you want to become a CMake expert, that's cool, and you have a lot of things to learn, but 99% of people just want to write their C++ code without having to deal with the build system. And people joke every time about beginner developers who don't read the documentation, but the truth is that 99% of documentations are horrible or non-existent or extremely superficial. And CMake documentation in particular is especially horrible. And whenever you want to do something specific with CMake, you won't find any answers online. So instead of searching the web for one entire day, you can just ask ChatGPT for help, and from my experience, it works very well. Don't say ChatGPT gives you bad information, because I used it to link my libraries to CMake and it worked. And it also helped me find some problems that there is no way you find in the documentation. Like for these things, it took me literally years to find out the right command with multiple tries that just failed silently. So when I say that for some things you just need to copy and paste my code or ask ChatGPT, trust me, it's not something you will easily find yourself. And if you are linking your C++ runtime statically, make sure you specify that to ChatGPT and say that you want that library to be linked statically to the runtime as well. Okay, so let's look through this CMake and see what we have. So first of all, you can see that I have the same project structure that you just learned about. So I'm not teaching you something I don't use. In fact, this is how all my setups looks. And I use this exact CMake setup for my Steam game. So we start with the version, and also set the C++ 17 standard for the current project. Next I add this variable thing here, and it basically specifies if I want to make a production build or not. And you will soon see how I use that, but basically, a development build means that I may want to include various extra checks and debug tools in the code for me to use as a developer, while a production build is a finished build ready to be shipped to people, so I may want to remove the console and other debugging tools. So for example, I enable whole program optimization only for the production build. It is a very nice optimization, but it takes some extra time, so I want to compile a little faster while I'm working on the project. Then I add an extra optimization flag here that you can ignore. Now we create a project and we link libraries. And here I do some specific thing for the glfw library and also for the libraries in general to not be built as shared libraries. This is why ChatGPT is so useful. If you search link glfw with CMake online, you won't easily find this. And by the way, whenever you find things with package find and install package, that has to do with installing libraries globally. And I really don't recommend doing that for these reasons. I just always put all the libraries that I need in the project. So moving on, we add the folders with all the libraries, then we add all of our CPP files into this variable and create our executable. Next I need to add this line to add a compile definition for glfw to work. And again, good luck finding that online. Next I do these things with the resources pass, but I switch it automatically, depending on if I have a production build or not. And I also set a macro for the C++ program. So I can also know inside my C++ program if I'm inside the production build or not. For example, in my case, I don't open the console if I'm making a production build. Next, if I'm binding with MSDC for Windows, I use this line to tell the compiler to not create any console for me. I want to do that myself only if I'm inside the development build. And if you used Visual Studio before, you might have seen this before. It's just to stop Visual Studio, throw annoying useless warnings at you as errors. Finally, I set some include directories, and I link to my libraries. So you can see that with only a few simple CMake lines, you have your entire setup that is up and ready to ship a game on Steam. So I have no idea how people manage to have bigger, more complex CMake scripts that don't even solve the problems that I solve. But I have two more things to show you, and then if you want to learn OpenGL or start a C++ project, I have many plug-and-play CMake setups for basically any need that you can think of. So I will link to YouTube videos if you are interested in just starting coding as soon as possible and dealing with CMake later. But now let's look at the last things, and those are how to add CMake to libraries that don't have CMake, and also the last learning example. So the third learning material is another older engine of mine that I made with some other people from my Discord. So if we open cmakelist.txt, we don't see much, and that's because I designed it so that multiple modules can be easily added by people, like you can see here. So I load the libraries, and then I load the modules, and that's it. If you look inside the module, it initially looks something like this, but then I moved the common functionality into a separate common file. So this makes it even easier to make a new module. But there is one thing to point out here. Don't split things into hundreds of files just because. Again, 100 lines of CMake is all you need for a simple setup that is easy to read and understand, so keep your things simple. And the last thing is how to make libraries with CMake and how to add CMake to libraries that don't have CMake. And it is something very simple but equally important, because some libraries may not have CMake. So if your library has only header files and no C++ files, it will look something like this. So very simple, and you can find this CMake in the first link learning material, so you can copy paste these lines. Notice the interface keyword here. This means that this library only has header files. Now I also wanted to add a test for this library. So to do that, I just need to add an executable to it as well, and that's it. If we look at this project structure, I have the include and src folders as expected. Now for the next example, go back to the second learning material link. So that means this repo with my CMake setup. And let's look inside GLAD. So we have again include and src, and I just place the right files inside. So if you do this for a library that doesn't come with CMake like GLAD or ImGUI, you simply need to add all the C++ files and header files to the CMake. Notice that I have a second folder inside include that has the same name as my library. To keep things organized, you want all your library includes to look like this, and to achieve this, you add an extra folder. While this way of coding header files for library is, I would say, standard, some people don't do it. So you might make your setup to include the files like this, but they wrote their code inside the library to work like this, and now you are getting compile errors. So in this case, either set it up like they wrote them, without the extra folder, or if the library is small, fix the include errors one by one directly in the library's code. So looking inside the CMake for GLAD, it's actually extremely simple and straightforward. We just add the library, we add the CPP files, and the header files. Notice the public and private things here. Don't worry about them. Just add them like that. And again, copy paste this code to make your own setups and not bother. If you look inside the GL2D library, however, one interesting thing to note is that I'm linking to other libraries, even though I don't have any line to tell CMake where to find them. Well, that's because you only need to tell CMake to search for libraries in the main cmakelist.txt, so this is nice. But for most libraries, you won't need dependencies. Finally, let's look inside stbimage. Now stbimage is interesting because it's a header-only library. Header-only libraries come with one header file, and you usually have to do a specific define in exactly one CPP file before you include the header file to also generate the CPP file for it in that existing CPP file. The simplest way to set up something like that with CMake and without having any problems is to just treat it like a normal library with a CPP file and a header file, and the CPP file looks like this. So again, a header-only library needs to add a special define in one single CPP file, and so this is that CPP file. Now, if you are wondering how do I know about this special define, well, you should find it in the documentation, or in this case, the header file itself, but you can just ask ChatGPT. And so, after we made our CPP file, the CMake looks again very simple. Now I would recommend you to try configuring some CMake yourself. And also, if you just want to use my pre-made CMake setups to write games or learn OpenGL, I have these 2 videos for you. And finally, if you found this useful, my channel does C++ stuff like this, so if you want to learn from me, you can subscribe, and also I release a paid community where I will help you one-on-one. But it will take some more time until I release that. So subscribe to not miss the launch and get the best deal possible for it. See you there!